Okay, here's a couple of questions where it's useful to look at angles in terms of radians. Just because we have these formulas, theta is equal to S over R, V equals R, W. There could be a couple other ones. Anyway, let's see which one we need to use for this formula. Bicycle tire has a radius of 34. Radius, so I could use either of those. If I travel 5 kilometers, how many times will your wheel go around? Well, so they're looking for revolutions. I know that either of these formulas, when I'm looking at this angle or this one here, it needs to be in radians. So I'm going to have to convert from radians to revolutions. Now the question isn't asking for speed, it's just looking for, it gives me a distance and a radius, and it wants to know the distance. Now, this form, I'm going to use this one. This S stands for arc length. And if you're looking at a wheel, and that wheel, say I go from here, and I go all the way around, that's what we're talking about, an arc length. But if that wheel is rolling, then the arc length is the same as the distance traveled. Okay, so I can treat this distance here as the 5 kilometers, and then the radius I have, and so this will tell me how many radians that were rotated. So how many times, not how many times it went around, but how many it's not degrees, it's in radians, but you get the idea that it's an angle. Okay, and then once I have the angles, I know that 2 pi radians is equal to 1 revolution. So then I can figure out how many times the wheel went around. So it's sort of going to be a two-step question. So the angle that an arc turns through is equal to the arc length, or the distance that it turns through on the arc, divided by the radius. So the distance, or arc length, that it goes is 5 kilometers, and the radius is 34 centimeters. Now right off the bat, hopefully you're looking at this and saying, well, hold on, they're different units, maybe I should change them, and you should. So to change from kilometers, it's kilo, hecto, deca, meters, and then decimeters. These are deca, decimeters, centimeters right there. So 1, 2, 3, 4, 5. So I've got to move my decimal 5 places to the right. So 2, 3, 4, 5. Is that right? Yeah. So that's, instead of 5 kilometers, I went 500,000 centimeters divided by 34 centimeters. Let's do that on our calculator here. So 500,000. Uh-oh, this might not work. 500. I've got to be in a place, oh, I know what I'll do. I'll just scroll down. It's better. 500,000. 500,000 divided by 34. There. 14,705. 14,705. 705.88, and this is, the units are in radians. So now what I would like to do is to convert that into revolutions. So that's how many radians the thing turns through, but now I need to convert it to revolutions, and I can use that unit there to do that. So 14,705.88 radians multiplied by this conversion unit. And I need to put the radians on the bottom so they'll cancel. 2 pi rads is 1 revolution. So I basically just have to take that number I had before and divide it by 2 pi. So I'll do that. So take this and divide by 2 pi. 2 pi. There. So 2340.5. So the number of revolutions are 2340.51. That's how many times the wheel would have gone around in 5 kilometers. Okay, let's try a similar question. Pioneer wants to know how fast they're walking. Oh, it's not the exact same because they're looking for a speed here. So they're looking for a velocity. Beside their covered wagon, they put a mark on one point of the wheel, which has a radius of 35, so that's a radius. And they start counting how many times the wheel goes around. If they count that they do 39 revolutions in 1 minute, what is their speed in kilometers an hour? Okay, this is a great question. So here are my formulas. Theta equals S over R, V equals R, W. So I have a radius, good. But they want to know what the velocity is. This is an angular velocity, so it's how many times something goes around in a certain amount of time. And that's, I guess, what this is right there. But the only problem is that W is always measured in radians per given time. And this one gives me revolutions. So let's fix that. So my angular velocity is 39 revolutions per minute. So let's convert that. I know 1 revolution is the same as 2 pi radians. So the revolutions cancel. So this will be 78 pi rads. And I guess I could take 78 and times it by 3.14 to get an actual number, but I'm just going to leave it like this and we'll do that calculation later. So that's what W is. So now I can use this formula. The velocity in kilometer or in distance per time is equal to R times angular velocity. So the radius is 35 centimeters. Let's make sure that that is the radius. Yeah. Often they give you diameter, so you got to make sure you cut in half. But it's radius, so it's good. Times by the angular velocity right here. Oh, and that was per minute. I forgot to put per minute there. So this is 78 pi rads per minute. Now I've got centimeters per minute. That'll be my unit. But I need to convert that to kilometers per hour. So I'm going to fix both of those. Might as well do it while we're in the same process here. I could figure the answer out here, but that would be centimeters per minute, and they don't want that. So let's first convert the centimeters to kilometers. So here it gives me that conversion unit. So there's 100,000 centimeters in 1 kilometer. So centimeters cancel. And then I want to convert minutes. So there's 60 minutes in 1 hour. Again, knowing where to put those things on the top or the bottom depends on what you have. So if you have centimeters, to get rid of them, you put centimeters on the bottom so you can cancel, and then the other one goes up top. Similar with minutes, I want to get rid of minutes and get into hours, so I put the minutes on top and then divide by hours, so the minutes cancel. So my final unit here will be kilometers per hour. So now I just have to multiply that out. Let me pop up some decimals here. Okay. Let me just scroll down a bit. There, I've got the whole thing. So I want to go, I think I'll put this in brackets. 35 times 78 pi times 60, so that's everything on the top, bracket, divided by, oh, there's only one thing on the bottom, 100,000. There we go. Good. So their velocity is going to be 5, and they went round to 2 decimal places. So I'd call that 5.15 kilometers an hour. So they're walking at a pretty good clip. I don't know if you could do that with a bunch of oxen and cows and wagons. But 5 kilometers an hour, that's a pretty good trip. You think about that, 10 hours a day, you could only go 50 kilometers. Yeah, I'm taking a bike. All right, hopefully that helps you with those 2 questions.